And so now for the binary search. For data structures which have a large number of elements, it is way more efficient than the sequential search. And we can only do it once we've got a successful sort accomplished with that data structure using the bubble sorter, the selection sorter, some other kind of sort. So here we go with the binary search. Remembering again, reiterating again, that to understand the algorithm of the binary search, it's much better to watch a video with a Hungarian folk dance or watch what we do with the cards on the table or me up at the board. But in terms of the code, this is the code, and I'll do a limited amount of trying to explain by moving my mouse around and describing what's going on, but mainly this is looking at the code and what the different parts of the code do. So binary search, called from another method, a main method in this case, so static return values and parameters. Parameters, well, we're definitely going to need to have an integer array sent. And we'll just call ARR. So we'll send this one already made. And the other thing that we will need is, since it's a search, what we're looking for. So let's look for 55. 55 is a number which is in this. So the second parameter is going to be, for an integer array, an integer key. Key meaning the key thing that we're looking for. And remembering once again that in this case it's a general binary search that I'm teaching, but this is only going to work for integers, so you might want to call this int binary search or whatever. So there are two parameters. Again, look to the videos to really get what's going on here in terms of the algorithm, but quickly, just so we can follow what's going on, what you do is you, with a sort of data structure, look in the middle and see if that's what you're looking for. But the middle would be, in this case, 0 plus 11 is 11. Integer division by 2 is going to give us 5. So if we jumped in the middle, this is the value that we'd be looking at. We're looking for 55, not 52. So that's not it. Since it's ordered, though, we know, since where we are at is lower than what we're looking for, that what we're looking for is over here someplace. So we can eliminate looking through all that. We determined this mid by taking a low and a high. Well, now we're going to determine a new mid, but we're not going to take that as the low. We're going to take this as the low. In fact, let's label all this. So I guess the first thing that we're going to be labeling as we go through is M and L and H for mid, low, and high. So let's get those established. The low and the high we can do right now. They'll be integers. Well, low just starts at being 0. It starts at being 0. It may change, very well may change, but certainly starts there. Int high starts at, well, it's this one, which is the length minus 1 because of 0 numbering, right? So high is going to start at being the array's length minus 1. Now the mid we could calculate right now too, but we're going to need to be calculating the mid over and over again. So, and we're calculating with the low and the high. So let's just get into our loop. And our loop structure, where again and again and again we're eliminating half, eliminating the half of the remaining, eliminating half of the remaining. We don't know exactly how many times we're going to be doing that. So it's not a for loop, it's a while loop. So we're going to go while. And let's just take this to the second iteration of the loop. If we were looking for 55, if we jumped in here we had 52, well, a new low is going to go here, and then high there. And you'll see as we go through this that the low and the high are going to get closer and closer and closer to each other. The low is going to creep this way, and the high is going to creep that way. And as long as the low is still to the left of the high, or even the low and the high could be in the same element number, then we're not finished looking. But it is possible that what we're looking for is not there, and it is possible that low could keep on advancing to the right so much, and the high could keep on advancing to the left so much that eventually they cross over each other. And if they do cross over each other, then we've looked everywhere, and it's not there. The element that the number we're looking for is not there, and so we can return some sort of indication that the search has come up empty. So let's for now just move back that L. So we will continue searching while low is less than or equal to high. So while the low is less than the high, now we're going to actually calculate our mid. So int mid is going to be low plus high divided by 2. It's going to give us that. Although be careful here because high divided by 2 would happen first in order of operations, so we will force the addition to happen first. Low plus high, 0 plus 11 divided by 2 gives us 5 with an integer division. That's the mid. So now that we have our mid, let's take a look to see if it's what we're looking for. If our array value at mid integers, so equals equals, if that is equal to our key, then, well, then we found what we're looking for. If we were looking for 52, and the first time through this iteration we found 52, well, then we've got it. So what do? We return the element where we found it. So when this happens, if this happens, we're going to go return the mid. We're going to return the index. We're not going to return the number. I mean, we could, but it's going to be much more useful as we get into object-oriented programming, and these things are not just simple numbers, but stuff, you know, several things as one object. Then, yeah, we'll want to return the index. So immediately we get an error because we've said that this is a void method. Well, it's no longer a void method. It's no longer void of a return. It returns an int. Still not going to be happy because methods which return something should return it as the last line, so we're going to make it happy temporarily by just returning a number. But in fact, we can pause right now and make this number what it actually would be if we end up getting down here. Because if we end up getting down here, if we end up getting to the point where the low and the high cross, and we didn't find what we were looking for anywhere in the array, we've got to return something. So what we'll return is a flag value. -1 will do. So the binary search up here, if it gets a -1, we'll print out something like, oh, it wasn't found. So anyway, back to here. Not always, obviously, when we low plus high divided by 2, go look at the mid, and look what we're looking for, not always are we going to find it immediately. It's going to be some other place. So else if what we jump in at, the value, is actually less than what we're looking for. So if ARR mid is less than key, well, what are we going to do then? If the mid is less than the key, it means that we don't need to look over here anymore. So what we're going to do is change the low to here and create a new mid to take a look at. So we're going to go low is mid plus 1. We don't make it mid because we've already looked at mid. We know it's not that. So the new low is going to be here. So the second iteration then is going to take the low and the high and see if low is less than high, and it is less than high. Low and the high, add them together, 6 and 11, 17, divided by 2, integer division gives us 8. So the new mid, second time through, is going to be 8. And if the value there is equal to the key, it's not. Else if the value there is less than the key, it's not. It's greater than the key. So what's the other thing that we can do? Well, we'll change the high, because since what we're looking for is now less than the mid, we know it's over here someplace. It's not over here. Let's eliminate that high and make it 1 less than the mid. The new high is going to be here. So what did I just do? I made the high equal to the mid minus 1. That's what we do whenever the value of what we're looking for is actually less than the key we're looking for. So under the third iteration, low less than high, yes. Mid is low plus high divided by 2. 6, 7, 13 divided by 2 gives us 6. So the new mid is actually going to be this. I'm going to put maybe slash mid. Okay, like that. If array mid equals a key, does it? Well, yeah, it does. Yeah, so we're done, and I guess it was worth doing this. Mid equals the key, so it's going to return 6. So let's just prove that that's working. This does return an int, so let's do something with it. Let's go int index returned. Sounds good. And then we're going to say if. Let's do the not found case first. If index returned is not equal, or just is equal to -1, well, what do we want to do for this teaching demonstration? I just sout the item looked array. Else, if it doesn't return a -1, it means it returned sooner or later the mid, where the value was. So, and we just want to prove that we got to index 6. So let's sout item was located at element number index returned. That's it. So let's run this. Element number 6. There you go. The iterative binary search.